Yeah.
Okay. Hello, dear participants. I am Divya S. Nair, Assistant Professor, Department of Civil Engineering, College of Engineering, Kidangoor. Respected faculty members and research scholars, I welcome you all for today's last session. It gives me an immense pleasure to introduce and welcome the resource person for today's afternoon session, Dr. Ranjit K. Soman. He is a postdoctoral research associate at Center for Systems Engineering and Innovation, Imperial College, London. He has a multidisciplinary background with strong experience in civil engineering, construction management, metro rail construction, augmentation and robotics in construction, etc. His PhD research was done in collaboration with Bentley Systems. He has done his BTech honors engineering from the University of Calicut and his MS in building technology and construction management from Indian Institute of Technology, Madras. He has published his research works in many journals and more than 11 conferences. He has won several awards for his novel research work, which include Best Poster Award by Center for Systems Engineering and Innovation, Imperial College London in the year 2019. Second place for 3-minute thesis competition award by the European Council on Computing and Construction in the year 2019. Place First place for corrosion awareness video competition award in National Institute of Ocean Technology General 2013. Other participants, please mute your mic. Sorry for the interruption. Please note. Sorry for the interruption. He is a member in various professional bodies like International Association of Automation Robotics in Construction, European Council on Computing in Construction, Indian Society for Technical Education, Indian Building Information Modeling Association. His areas of interest are automation and robotics in construction, IT application in construction management, building information modeling, virtual or augmented reality in construction, image processing for construction related process, etc. On behalf of Department of Civil Engineering, Kidangoor, I welcome again Dr. Ranjit K. Soman for today's session. And thank you very much. Over to you, sir. Ranjit, sir.
Thank you very much.
Okay.
Thank you for the introduction. I'm just checking whether you can see my screen now.
Yes, sir. It's clear.
Okay. So thank you very much for the introduction. So today the topic that I will be discussing is modular and industrialized construction. Which is not a new topic at all. It has been around for a long time, which came and went at some point. But at this juncture, in the construction sector, there's a lot of uptake on this particular technology. And over the course of this presentation, we would discuss why it happened and what do we need to know about it from the basics and where are we going. So that's mostly about today's presentation. So I would like to thank the Government Engineering College, Kidangoor, and the faculty who's responsible for this faculty development program for inviting me to this session. It's I think everyone who's a part of the session would enjoy this outlook towards the construction sector. So the first and foremost, what is industrial construction? So industrial construction is a construction method that borrows the concepts related to manufacturing sectors, production processes, which follows a design, manufacture, assemble, in contrast with the traditional construction workflow, which is like design, construct, operate, and approach. So before going into the presentation, I would just give you an overview about what we are going to talk today. So first, I would discuss a little bit about the college that I'm coming from, the center that I'm coming from, a little bit of housekeeping on how to interact during the presentation. Second, we discuss about why should we industrialize construction. Third, I'm getting a little bit of noise from audience end. Yes. So third, we will be discussing about some of the manufacturing paradigms. We're doing this manufacturing section because there are a lot of similarities that we are seeing in the manufacturing, which was in 1900s, and the traditional construction methods that we have, that we are seeing right now. Then we go deep into industrialized construction, what project process and platforms are, a little bit into digital configurators, and finally with a conclusion. So on to where I come from. I come from Imperial College London, whose mission statement is to provide the best research and education in science, engineering, medicine, and business for the best benefit of society. Previously, I was associated with IIT Madras as well as Government Engineering College, Thrissur, where I did my BTech. With respect to international ranking, Imperial is in the top 10 for the consistently for the last 20 years, and with different places in different framework. And it's one of the highest research universities in UK. With just science, technology, engineering, and business, without arts, unlike the other two main universities, which is Oxford and Cambridge. And particularly, I come from the Center for Systems Engineering and Innovation, which is a center, interdisciplinary center, which is located in civil engineering, but serves as an overarching center for interdisciplinary research within civil engineering, as well as other departments. And one of our main aims looking at 2030. So we had our 10-year anniversary last year, and we have the new aim for the center, which is on achieving maximum resilience, safety, and sustainability in the infrastructure sector. For that, we have 4 strategic themes, and it supports 2 main themes. That is, one is transforming construction, with which this particular part of the presentation comes from, which is about industrialized construction. Also, the second theme is on how can we achieve net zero pollution or carbon neutrality in the infrastructure sector in the coming years. So the main areas of research that we look at is looking at complexity and resilience. So when we are looking at very large projects, it's complex, it has multiple systems, and how do we manage such mega projects? The second theme we are looking at is systems integration, which is to make all this complex project work together. How can we isolate it as different parts, then bring it back together? Another theme is about data-driven systems engineering, which is about how can you use machine learning and the advances in technology to achieve the systems integration and better inform projects. The third one is about restart, reset, and reinvent. So we are looking at how can we use systems engineering to actually reset the construction, change from traditional construction to a newer method of construction. Then we are looking at infrastructure life cycle. So we're not just looking at the design on construct the whole cradle to cradle approach. So how do we conceptualize a building, build it, operate it, and at the end of the life cycle, can we reuse that building for something else? So we are looking at how a building is at a cradle to the next cradle. Then finally, on how can we achieve carbon neutral to net zero pollution. It's not just in the buildings, but as an infrastructure, which includes transport systems, which include power system, energy systems, everything together. So that's with the center where I'm coming from. For this particular presentation, I have a few acknowledgements to make, because these are the 2 people, Professor Jennifer White, who was my supervisor for my PhD, currently head of school at John Grill Institute of Projects at University of Sydney, and also co-director for Center for Systems Engineering and Innovation at Imperial College London. And Professor Daniel Hall, who's the assistant professor of innovative and industrial construction at ATAL Zurich. And there is an amazing industrialized construction lecture available for everyone freely on YouTube by Professor Daniel Hall, which I'm putting a link onto here. And I would also like to thank a little from the industrial side, Langerook and Maze, who are one of the major, two of the major contractors in the United Kingdom. So they have a lot of innovative approaches in their um, firm, and they actually gave us opportunity to study them, understand them in detail, both at the construction side as well as in the factory side. Then there are like two, Bryden Wood, which is a forward-thinking consultant in UK, who have made a lot of digital tools and configurators for achieving this industrialized construction. Soil Build Construction Group in Singapore. So they have an amazing supply chain and construction factory within Singapore for manufactured buildings, and they gave us a really good opportunity to visit their places, share their understanding, and collaborate with them. Um, I would also like to thank two industrial academic bodies. The first one is Industrialized Construction Forum, which is out of Stanford, but currently a combination of academia, industry working together towards excellence of industrialized construction. And second is a Transforming Construction Network Plus, which is a Innovate UK funded research network in UK, who has done really good work on both industrialized construction as well as on the work towards achieving net zero carbon in the construction sector. Next, I would like you to do a simple task. So I'm going to use a particular tool called Mentimeter to actually interact in the classroom. So in this virtual world, it is really difficult for us to look at to get the audience responses. So chat is a good feature, but the problem with Teams and other online conferencing modes is that we cannot, as presenters, we cannot see the chat directly because we are using like a single screen to present as well as present and get feedback. So what I'll do is what I want you to do is simply go to this particular website on your browser, on your mobile or something. It works for everywhere. So it's called menti.com, menti.com. And once you go onto this website, they will ask you for a code. So you just need to type in 41391075, and it will land you to a page with a question. So and the questions change with as the presentation progress. So what happens is like whatever you answer in the question, it comes straight into the PowerPoint screen. So if you have tried going into the website now, the first question that you might see is like, how is traditional construction different from manufacturing? And you can answer that question now or later, but just to make you understand what you might see when you go into this particular screen. So all you need to do is go to www.menti.com on your computer. And when they ask for your code, you just need to type in 4139 or 1075. Alternatively, you could scan this QR code, which should take you to the same page. But the most robust method is menti.com 4139 1075. I'll just leave 10 seconds so people can do that. Okay, moving on to the first part of the main presentation, that is on why should we industrialize construction. So we all know a lot of things about the present construction scene. The first one is most of the construction projects are unique. So whenever we start a project, we start with a blank drawing board and start working on the project. And in the end, what we get is a unique project. There is, for some of the residential construction, like multi-story buildings, there might be something that we might take from the previous project and go on. But in the end, what we strive forward is to make projects unique. And how do we build projects? It's mostly with construction project teams that are unique. So one set of people working on a project might go into the next project. Some of them will be retained, but there would be new people coming in, and some of the existing people in the team goes away. And what is the problem with that? All the knowledge that is gained in the previous project, it gets dissolved when you come to the new project. And it's only, so the problem there is that even though you are retaining a lot of knowledge from your experience, it's completely in the people's individual knowledge rather than as a firm or a company. So whenever people leave, the company is losing a lot of asset from their perspective. And also what happens is when a new person is coming into the team, it takes a lot of time for them to learn the company processes, etc., or the company's design philosophy. So can we make that, can we make the projects unique, yet makes project teams understand that better? And there are a lot of cost associated with changing teams, which is studied under the big heading of transaction cost economics. And all of the projects are built with one-off technical solution. So it is rarely, even though we are doing the same process, let's say how to design a column is the same throughout the all the kind of buildings or infrastructure that we are creating. It's all done from zero to all the 100% every time. We're not starting from a 50% level, or there are not many existing technical solutions that are there. So in a simple word, we could say, and our industry is building prototype every time. So every time we are creating something new. Whereas if you look at something like your smartphones, let's say iPhone, it came from iPhone 1, 2, 3, all the way to around 12 or 13 right now. And every time there's more improvement. It might look a bit same, but there's a lot of more features added. It becomes better every time. And within a short span of 10 years, it has improved so much. Whereas if you look at construction sector, we have not. I'll come to that later. And the second thing is building processes fragmented. So we have a lot many stakeholders and interfaces in the construction sector. In a simple project, we might have an architect, a contractor, and maybe electrical, plumbing, etc. There's another contractor, and then the client. If you go to a major project, it would be like the client. There would be a project management consultancy, the architect. Then there is a whole suite of designers for structural, architectural, mechanical, electrical, and plumbing. Then there is contractors, and there's a lot of subcontractors who construct the building. Then there is a lot of admin associated with it. So when we are looking at construction, we have to actually organize around a lot of stakeholders who may or may not have worked together previously. And when we are looking at the present construction scene, what we need to look at is about this. Have we got healthy working conditions for everybody who's on construction site? So when you're looking at statistics, we could see that 1 in 5 deaths among the US workers is from construction sector. Falls, that is falling from a height, accounts for around 33% of construction deaths, and eliminating these falls could save more than 300 lives. And injury rates in construction are 71% higher than the injury rates across all industries on an average. So that is not a good metric that we should look at from the construction perspective. We need better health and working conditions. The next thing is about sustainability of construction. Do you know that construction sector accounts for around 39% of carbon dioxide emissions? And most of this carbon footprint come from embodied carbon in the content in the material. So we are not even reusing it, and we have more waste than any other industry. So I'm not sure whether you would believe it, but a study at IIT Madras has shown that around 60 to 70% of the materials, not just materials, the whole value is being wasted on a construction sector. Now, do we have good coordination? I don't think so, because we have seen that most of the projects are getting delayed. Most of the major projects are delayed, that is by 5 to 10%, smaller projects less, and some of the more complex projects even to a longer scale. And it's not unique to one country. We have projects getting delayed in India. If you look at it, the Crossrail project, which was really kind of like a trademark project or kind of like an excellence project that got delayed around 3 to 4 years now. There is the infamous German Brandenburg airport, which was supposed to open in 2013, has not opened still because of problems with integration. The building is there, everything is there, but no integration. So all these points to like lesser coordination in our sector. Do we go for a safety first approach? Not necessarily, because we have seen the kind of like problems in construction with respect to safety. Finally, do we have an effective supply chain? No. Our supply chain is again fragmented. So every project we have a new supplier, we don't have long-standing relation with them, resulting in delays. So if you look at our industry, the construction sector is around 8.26 trillion industry. It contributes to 13% of the global gross domestic product. It develops and maintains the environment and is responsible for about half of the worldwide carbon emissions. And a recent study by McKinsey has led that even a 1% increase in construction productivity would save around $82 billion annually. And when you look at that $82 billion, that is equivalent to money spent on cancer drugs annually. So think of what we can achieve by even 1% productivity improvement. And we don't have a high production facility or conditions for a high quality product, because our production facility is the construction site itself. And construction site is actually subjected to a lot of problems like weather, winds, dust, etc., which reduces the product quality. So those of you who have worked in a construction site would know that you were planning for concrete pour and there is rain, you have to stop it, then you have to do it again. So there's no control over the outcome to a great extent. That is why a lot of rework come into the construction. A little more about the productivity. So on the graph on the left, you could see 3 lines. One is on construction, one is the total economy in the world, and one is manufacturing from 1995 to 2014. What we can see in the general trend on the total economy of the world is it almost increased by 50%. So from 1995 to 2014. Manufacturing, it almost doubled. Whereas in construction, a mere 3 or 4% increase to the most that we can see in that graph, not much. And if you look at the annual growth or hourly growth, manufacturing has got a lot of increase, which is around like 3.6 times, whereas construction, not much. And if you look at the construction sector across the world, there are like laggards who are not the best to adopt new technologies. There are like outperformance, and India is kind of like coming in that particular area where we are open to adopting technologies, but we are not outperformers. So what we need to understand is like, what we need to go from here all the way to here for better productivity from the construction site. And that's where the idea about industrialized construction comes in. So why should we industrialize construction? We have poor productivity, low quality, complex production environment. We have low profitability. So if you look at the profit margins of any contractor, you could see that it's almost in that 1% range, whereas other sectors, they are looking at like 10 to 30% range. And the problem with that profit margin, there's a lot of loss, probability for loss, and also lesser gains that could be put back into research to create better products. Also, a few other factors. We are looking at a global housing crisis. So by 2050, we need to have as much residential buildings as we have now doubled. And that is like we need to construct it in less than 30 years. So what we have constructed all this while. our construction workforce is decreasing. So we need to find better methods for construction. And the last but not the least, lack of available materials. We all have seen how much we have exploited our Mother Earth, and we need to look at alternative sources or reusing what we have, or at least when we are constructing new, we need to think about methods in which we could reuse the materials at the end of the life cycle. So these are why we should industrialize construction from my perspective. Now, over the next few slides, we will just show what an industrialized construction process is. It's not exactly an industrialized construction process, but a sneak peek into it. There are a lot of missing elements, but still. So first thing is we start with a design, and that design is taken into a factory where it would be manufactured, and you could see the kind of machines and robotics involved in factory. So this is the soil built factory in Singapore. And they have this is just like one of the planes where they're bending the rebar and doing it. So you could see that it's more faster than the traditional process, and also it's more efficient. You have uniformity around. There is a lesser probability for errors. Then it's manufactured as modules, and these modules are transported to sites in a truck, and then it is lifted and placed in a particular point. So on the left, you would see like a construction site in Stratford and UK, and on the right, you could see a particular module which is built, taken up, and placed in the predetermined position. So there's kind of like a shell structure, which is the core of the building, and the rest of it is built around it through the assembly. And what comes in the module? So if you look at inside the module, it's almost completely finished pieces. So here you could see that there's a little bit of a lining over the floor, but I would tell you like flooring is completely laminated and completed. You have all the appliances installed. For instance, the wash basin and the bathroom port is installed, the toilet seat is installed, the shower, all those plumbing appliances. So all these take a lot of time on construction site, and the finishing work is challenging. So all of those are installed. Yet we leave some of it open. It depends. Some companies do it completely. Some companies do a little bit open for the customers to choose from, etc. And the outcome, this is how it looks like. So on the left side, you would see the building, which is, I'm not sure of the name, but it is in Singapore, which was in 2019, when I visited them, the highest modular constructed building in the world. And this is how it looks like in the inside. You wouldn't see a difference. It looks exactly like a newly constructed home. So that's what the idea about industrialized construction. In a broad senses, we will go more deep into it, looking at the philosophical elements of industrialized construction too. So on to the first part of the question. In the Mentimeter, how is traditional construction different from manufacturing? I think almost like seven of you have answered using the mobile phone. I mean, you can still answer it. So I will just go through the question, the answers here, and might talk about it a little more. So the first, construction is a project, manufacturing is done after project is completed. Maybe, but construction, so we will come to projects and processes later on. So we might answer that question later. It is very much different as it needs a different category of workers. I think we'll answer that question when we come to, that comment when address that comment when we come to manufacturing. Precast manufacturing is done without requirement of a specific work. It was not currently. We will again discuss that later. So I think these comments are really good because we're going to discuss each of this and addressing it. Traditional construction takes a lot of time to complete. Yes, that's why we need a new method. Traditional construction is time consuming, labor, equipments are not used in traditional. Yes, that's a good observation. Manpower is more for traditional, skilled labors are required. True. manpower is more in traditional construction, it is time consuming compared to modern one due to the usage of old techniques and equipment. Yes, that's again true. Do we have any more answers coming in? Wait for probably 35 seconds to see if there are new answers. Otherwise, we'll proceed. But overall, I think these are really good observations. And I think this is kind of like the path we would go through in the presentations also. But what I would like to tell you is like some of these were already there in manufacturing and it changed in a while. So I have 7 answers. We have around, let me see. We have around 100 participants. You can still go to minty.com, put in the code 41391075 and key the answers in. The question is still open, so you can do that even now. So the code is 41391075 and minty.com. So yeah, since no answers, no new answers are coming up, I think we'll go on to the next slide. So can industrialized construction help? So that's the question that we are looking at it. So we have some problems that we have seen here in the comments and from the previous slides. So something regards to the time, problems with equipment, etc. So all those are like true. So can we mitigate that with industrialized construction, or should we treat it as traditional itself? So for that, first we need to look at how manufacturing evolved. And why we are doing this particular idea is to look at, is our traditional construction something in line with manufacturing in the past, or is it different? So first starting with craft production. So this was the manufacturing process before the Industrial Revolution. So in craft products, there was a highly skilled workforce. So they were really good at doing something. Just like if you look at even now with Rolls-Royce construction, Rolls-Royce production, it's all hand-built and everybody has a specific workforce for a particular part. Similarly with some of the watches. So if you look at a Rolex or some of those watches, the Swiss-made watches, you could see like they're like really good workforce in a particular thing. So the in manufacturing, it was like that all through, and handmade was kind of like a thing. And where is the parallel to that in traditional construction? We also need highly skilled workforce for particular trades. So we have like carpentry, we have a little bit of like a lot of custom-made things, and certain people are really skilled in that. So they are the people who were called artisans with a source of pride, and they use general purpose tools. So somebody made a comment about tools in construction that we have general purpose. So similarly, in the manufacturing, they were using general purpose tools. So everybody had a kind of like a particular set of tools, and they were they were completely using the general purpose toolbox for everything. They don't have like unique tools which increases the efficiency. Then they had like a unique final product. So we did talk about construction. Every project is a one-off technical solution, and it is like unique. And just like construction, they were doing prototypes every time in a way. And there was a long process of custom fitting. So we were talking about the traditional construction and how it takes longer to fit. Similarly, the craft production back then took a lot of time to finish. So they were custom fitting everything. There were problems. They came back, they did rework, came back and did it. And that's how it was done. And the supply chain that was fragmented. So there was no long-standing relationship. So every time like a company was there, they did something and they manufactured something, then they went out of business, new people, and they don't have like long-standing relationship, and the supply chain was fragmented. And the organization of the manufacturing, it was decentralized. So everybody was doing a little bit, then it comes together. So if somebody has a problem, then the whole line, the manufacturing gets delayed. And even that happens currently. If you look at the chip shortage and the um, computing world, which was caused due to a simple problem in the Suez Canal last month, you could see that there are problems even still. But what we see is like our supply chain is more robust now. We can get things shipped out from many part of the world and still get a product within a short amount of time. So if you look at this era of production in the manufacturing, um, early 1900s or before that, it was very much similar to what construction is like now. Then came a revolution, and it was this particular idea about mass production, in which they had kind of like a different philosophy. They were producing the same item in numbers. So it's not like a unique final product, but some of the other things, there are no general purpose to. There were like really good tools which are being created to do a particular process alone, and they produce stuff. But what is the problem with that? There is no customizability. So this is kind of like a quote from Henry Ford, the man himself, which is any customer can have car painted in any color as long as that he wants it, as long as it is black. So that means he can only get black cars. So there's no choice for the customers. And I don't think that's the way we want our building to be. So there should be customizability, as many of you have pointed out in the Mentimeter. So just going on to the question, how did this idea about mass production succeed? Was it the assembly line in which a lot of things are produced together, or is it something else? So if you go on to the Mentimeter, again, you could key in some of the answers to this particular idea. So you need to refresh your page in your phone or the browser. So go to menti.com for 1391075 if you haven't already. But if you have already gone it, you could just refresh the page, and there would be some of those fields, input fields coming up. Once you submit, I can see your answers here on the screen. So I haven't seen anyone responding yet. Just wait for a few seconds. Yes, so we have seen some answers coming up. So the first one is chance of error is less. That is partly true. Production cost reduced. Yes, that is that is also true. So the chance of error is less is not completely true, because there were errors coming in the assembly line or the mass production also, because some of the errors. If you look at the book called the goal chance for ongoing improvement by Goldrick Cots, you could see like that in the assembly line construction, whenever a product is going on, the quality checks are at different levels. So there were errors coming at some point, and it was realized later, and a lot of errors kind of like grew on the product, and they had to ditch it. So those were problems were there in it. Production cost reduced, obviously, because we are doing the same thing again and again. Can meet the demand. Yes, that's true. I didn't understand the comment for major projects. I'm not sure. It is economic. It saves time. Is that true? My question is, why did it succeed in terms of like how that mass production itself succeeded, why it was taken up? So all of these are for me is like outcome of the mass production.
Okay. So
Getting Yeah. Okay. So is there a question on the?
Appu sir, please mute the participants, sir. Totally.
Okay, muted, sir. It's now okay, sir.
Okay. So we will just move on. So in this idea, there was a big study looking at the success of the mass production system by Womack and Johns in 1990. And the idea of the success is the simplicity. So everything was simple. It's not like you need a huge skill set to assemble it. There were interchangeability. So whenever something fails, there are like things which you could change to get it, and everything logged on to each other easily. So there were not a whole bit of tools to, idea to do it together. So it attached very easily. So when I was doing my undergraduate BTech, we had a series of mechanical workshop. So most of the times where we failed is kind of getting that right knack in the dovetail joint or something like that. So it was very difficult to attach. So you need to have like a lot of measurements from right, left, top, and bottom to get the pinpointed position where we start drawing. And all this getting together, like getting that right position took longer time than actually building it. Similarly, if you look at some of the layout and construction, it's the same. So we were looking at a study in which we were looking at augmented reality to understand which points to drill in a construction site. So that again took a lot of time. That's why we came up with this augmented reality where machine projects everything to the wall where the drill point should be. So all of those things comes to be like interchangeability, where to place a stuff and what's stuff to place in that particular position. All of those comes exactly in an assembly line. So that's how the mass production succeeded. That's why we could do better time. So because it's easy to attach, you reduce the time for preparation for attachment. And so the a particular car or whatever it is being manufactured moved from one station to the next very fast. Then even then there was problem with the idea about errors in the system. So the problem with errors is like it actually grow after every station, and then at the end it was like something like a car has to be discarded, it cannot be replaced. So that's where this idea about Toyota production system and lean production came into picture. So first it was about creating the stuff fast. But when they were doing it fast, they could see that there were a lot of errors and there was a lot of revenue loss because of the quality control. So in Toyota production system and the idea about like lean production, what they did was it started reducing errors. So for every bit of work, they were looking very hard to reduce the waste. So waste is in terms of materials, waste is in terms of money, waste is in terms of time. So they categorized every work into three categories. The first one was value adding work, which means like placing a part in a car, which is like there is a final value for the customers. Then there is non-value adding but necessary tasks. So taking the engine from like the warehouse into the assembly line. So that's not a non-value adding activity for the customer, but it is a necessary task. Then there were like non-value adding tasks. That means there are a lot of like rework or you placing something in the wrong place and then you have to remove it and replacing it. And they were doing the whole manufacturing line, looking at these values. So that process is called value stream mapping, and they categorized each of the method that were non-value adding, and they started removing. And they were increasing the points of like quality checks. And what happened in that is like it reduced errors. So mass production could produce a lot of things in a really short time, but there was no customization and there was errors building up. In the lean production, you are still producing a lot of stuff with lesser number of errors, but still we are not getting the customized product. So that is lean production. So what happens is like we have highly flexible machines and automated machines. So we're getting high volume, high variety. We have less labor, less inventory, less rework. And this is the place where they came with like really special tools. So every process has a special tool which reduces the problem with, the effort on the person who's assembling, as well as the effort on the, increase the quality, because there were like torque wrenches which just does the correct torque, so it won't, the particular tool get, the product doesn't get destroyed. And there were a lot of things like very easy to do. So if you are using a standard screwdriver in a remote kind of like thing to tighten a remote screw, it's difficult. So they had a special tool for that. So it just clamps on, you could do it and take it out in lesser time. So that was lean production. So as I stated again, we didn't get customizability. So that became a problem within the manufacturing. That's where the idea about agile production came into it. So here they combine lean production with customizability. So the customer can create a product order that goes into a production plan. Then that is, there's kind of like a sequencing done so that a customized product can be manufactured in the same manufacturing line. So every time, so there's a lot of information management that is taking the customer's requirement onto the manufacturing line, and the automated machines, etc., could actually understand that and produce the customized product. So the product information is taken, it is incorporated into the production line, then the production is done efficiently. Then if you have like a particular part, those are already there in the production line before even the production line starts. So by the time that particular work order reaches your assembly station, you get those parts and it's easy to assemble because it's interchangeable. And finally, it's delivered to the customer. So that's what agile production is. So we started with craft production, just like traditional construction. Then we went to mass production where there is no customizability. Then we went to lean production with lesser number of errors. Then we are at agile production. So house production or infrastructure is somewhere in this craft production stage now. That is in 2021. So what we need to do is go straight from here to agile production. So that's what the idea about industrialized construction is. Now, we talked about automotive sector. So some of you might think it's not a directly comparable thing because our things are really large, has a lot of parts than a car or something that is manufactured. So we look at airline. So even in airline, it's a similar manufacturing process. So it's really large product. It's of the same value of some of the buildings that we are building right now. And the products, the components are coming from around the world. It's being manufactured at different parts of the world, but still following manufacturing philosophy so that the errors are reduced and things are delivered on time. And if you look at the number of parts, there are around 6 million parts in a Airbus A380. So can you estimate how many parts might be there in a building, which is like 7 floors tall, 420 rooms, 40,000 square meters? So we, just for comparison with the assisting trademark. So again, if you go to menti.com, put in this code, you will see this particular website. And then you can start doing the quiz there. So I'm just waiting for you to key in. So we did this. As a research exercise a lot of times with academics, industry, academia collaboration, etc. So we have like 3 scales: 0 to 1,000, 1,000 to 10,000, 10,000 to 100,000, 100,000 to 1 million, and 1 million to 1 billion. Okay, we've got 2 answers in the 100,000 to 1 million, 3 answers in the 1 million to 1 billion. And I should say there are no correct answers to this. So there is, so after our like conversations, etc., there's a paper out of Stanford, which exactly looks at this idea. So we are seeing like multiple answers. So consistently, I'm getting like 7 people responding to the comments onto the Mentimeter. So I'm just moving on. So this was just a simple exercise to increase interaction. So when you're talking about this 100,000 to 1 million or 1 million to 1 billion, what do you think a part is? Again, if you could put it in the Mentimeter, that would be great. So is it an object installed as one piece? Or is it kind of a logical level at which a design or object is irreducible and unique? Or is it a combination of systems that work together or to provide function? So those who have answered the question earlier, could you please put in your rationale? So that 25,000 is an answer. I'm more like thinking like, when you say 25,000, what is that one unit, or what do you mean by that one part? So manufacturing or other systems has a definite answer to that. But what do you think is that answer to that question? So foundation, floors, walls, beams, columns, roof, stair. Okay, that could be one part. That could be one part, as in basically. But can you do, if it is a wall? If it is a wall, is every brick a part, or a whole of a wall is a part? Or in a column, is rebar a part, or the whole column as a part? I think I'm getting some noise. Okay. Okay, that's coming as similar type. Yeah, probably. So, I mean, these are good answers. So again, foundation, wall, foundation. Okay, it's kind of like the same answers coming up now. Okay, we will move on. So again, the main idea is that there is no uniform definition for a part in construction. So it could be anything. So we can look at a door frame. We can have a high estimate of like 46 parts, in which we are taking in every element like door frame, door panel, door trim, left jamb, right jamb. Or we could have like a low estimate of parts like door frame, door jamb, and the center part is the same. Then there are like screws which we need to come in. So it depends on like how it is being built. So some of these parts would be like the frame, and all those parts will be built by one person and the rest by another one. So again, if you look at a ceiling, there can be like a high estimate of 24 and low estimate of 10 parts. It is like a 20-meter square area. There can be high estimate of like 333 and low estimate of like 139. And this was carried out in this particular example of the building that we stated earlier, which is the 420 rooms, 7 floors, stalls, 40,000 square meter. And what was understood was there were around 3.2 to 4.6 million parts, and there were like high estimates and low estimates like this in interior services, etc. But still, that's dependent. So we do not have an idea of a part. So we talked about the manufacturing paradigms. We talked about how traditional construction is similar to craft production per se. We talked about how manufacturing moved on. We talked about what is a part and where as infrastructure we should move in. So how do we adopt these learnings from the manufacturing into construction? So that's where I'm going to go next. So is industrialized construction just about prefabrication? Or will prefabrication in isolation help? That was a question that has been there a long time. And previously, people were looking at it too. And in 2006, there was a research which came in and told that's not enough. So industrial construction should have 7 items, starting with planning and controlling of process all the way to continuous improvement. So those are the learning from the manufacturer. It's not just about prefabrication. Prefabrication is there, but just one part of it. So first, we need to plan and control process. So whenever we are thinking about constructing a building, instead of going it as one-off, we should have a definite processes on how it should be done. It should be structured and systemized throughout the organization. Then we need to create technical systems. So technical systems are like the wall part, sub part, etc. So we will go into that a little bit later. Then we should have a prefabrication element. So this is just one part. And if we need to do prefabrication, we need to have long-time relationships with the vendors and suppliers so that we can have like consistent quality all through, and we have better reliability because we know they will deliver and they will know that we will give them an order. So they will have like priority. So that's what is happening in the manufacturing. So similarly, we need similar long-term relationships here. Then we need to think about logistics. So unlike traditional construction where we are building it, everything in a construction site, we need to think about logistics on where to place a factory such that there's lesser cost and lesser carbon footprint of things coming into the factory and also coming out of the factory to the construction site. So we need to think about all this. And good thing is that there are a lot of research out there from manufacturing which we could reuse here and within construction also. You need to think of a lot of information and communication technology tools, both for the design, because we are not starting with a blank page, but with a set of components which comes together. So will they fit together? Can they fit together? Does it satisfy the regulation? How do we manufacture it? What instruction should we give the manufacturers? How will it get transported? And how can we track it? All those things. Important part, every time we are doing each of this step, we need to measure and try to understand where the bottleneck is improved. So that's come from the lean construction on identifying the waste, categorizing everything to value adding, non-value adding, but necessary, and non-value adding tasks, and removing the non-value adding ones to make things better. We should have a good customer and market focus. So we need to understand what customer needs and not push it. So there's like two kinds of philosophies in manufacturing or anything. That is push-based philosophy, where I make something and push it to the customer. And the other one is pull-based philosophy, where we look at the customer, understand their needs, and then create that. So if you look at mass production, it is a push-based philosophy. You make something, you ask customer to buy it. Whereas the agile one is pull-based, where you look at the customer's needs and bring that together. And finally, but not the least, we need continuous improvement. So whenever we are learning something, we need to start improving it, the thing as early as possible. So industrialized housing is not just about prefabrication, it's about a lot of things together, which gives a better thing. Now let's see how the prefabrication, the industrial housing progressed over the years. First, we started with the idea about just prefabrication alone, where there is a structure and we just manufacture the building and place it on top. So this was mostly Japanese house building sector all the way from 80s. Then we thought about like, okay, bringing customization. So we did exactly as the same. There's an architectural and structural designer. Then there is a split designer. What they did was like, they broke down whatever the architects and structural engineers or MEP engineers were creating, tried to break it into a discrete structure, then gave it to the manufacturing, and they prefabricated and construction company assembled it. Still, the problem is we are starting off it as a one-off solution every time we are creating the design and delivering it. So only the idea is like it is manufactured instead of constructed. But in industrialize, we should not start from a blank sheet. So currently, what we are looking at is something called platform-based approach in industrialized construction. So we have a standard set of parts which can be improved after every iteration. And each part has defined connections or interfaces. So these connections and interfaces are what makes it different from the normal thing. Then there is standardized manufacturing process. Then these parts and connections can make sub-assemblies, and the sub-assemblies can come together as buildings. So in a simple way, let me explain it, what it is. So as a product, think of a washing machine. So a washing machine can be, you can buy a washing machine in from different manufacturers with different features, etc. But it will have some of these things common. It will have a specific water inlet. It will have a water drainage. It will have an electric connection. All these three interfaces would be standardized, so it can go in. And in some of the later things, at least in the newer kind of construction, you could see like a washing machine embedded in the kitchen wardrobe or something like that, embedded into the house. So it will also look at what the dimensions of the washing machine is. Or as a change, like if it is a fridge also, fridge just had one connection. I chose washing machine because it has like 3 interfaces. So we have standardized interfaces, but we can choose from a lot of suppliers. We have better product variety, and it can still go into your same kitchen cupboard. And the kitchen cupboard would have a certain interfaces. That is, it should have an inlet water supply, outlet water supply, and an electrical connection. So all these interfaces and the dimensions, like outer dimensions, if you are correct, you can bring that washing machine and place it. It doesn't depend where you are buying it from. So that's the idea. So the component is a washing machine, or the product is a washing machine. The connections are the interfaces. And for the washing machines, there's like a standardized manufacturing process. We could create sub-assemblies of washing machine because like multiple things come from different places. Then we are building it together. Think of the same as a wall panel or window or etc. All are manufactured, and it has specific connection. It goes in together. So we are doing it partly in construction. Let's say bathtub, it's partly assembled and coming into the our construction site, right? Similarly, we are going a little more further. Can we do a whole bathroom together? Can we do a kitchen together? Can we do a bedroom together? All those things. So we will have a platform, which is the idea about like components, connections, processes, and sub-assemblies coming together, and it comes on to a building product. We'll go on to this more a little bit further. We also think about a lot of things in that process. So we can have prefab. So there's a lot of robotics in there. We also think about like how do we place these things together in a construction site? So there are again robotics and stuff that can do things which are borrowed from the traditional construction process. And when we are thinking about this manufactured component, it's going to be heavy. So there are a lot of things, associated technologies on exoskeleton, etc., which helps people place it together. There are like some of the things has to be like manufactured precisely with customizability. So we are thinking about manufacturing techniques such as 3D printing for that. Then there are a lot of robots which actually assembles this on the site. So it's called single task robots, and those things are really doing it faster than other previous things. So that's an idea about like industrialized construction. So we talked about what it is and what it is not, or the old view and the current view, and how our outlook towards it is. Now we think about project, process, and platform. So in the Mentimeter, there was an idea about a project, etc. So we should have a tighter definition around those. So what is a project? So I just took this diagram up, out of like a REBA plan of work, which looks at a project. So a project would have a strategic start and end point. So it starts with a conceptual definition or a strategic definition and ends with the use or end of the building. There would be a series of activity. For instance, the strategic definition, preparation, concept design, spatial coordination, technical design, manufacturing, handover, etc. And for each of these activity, resources are allocated, and in essence, it's a unique. It comes unique, and it only exists once. Then we have process. Process is continuous flow of activities. It uses information and resources, but it does not have a clear start and end point in time. So traditional construction is all about projects. Manufacturing is all about processes. Can we bring these two together? That's what industrialized construction is about. That is bringing about a project in a process format, so we can have all the advantages of the process as well as the project. And that's where we need platform. So what is a platform? So platform is a set of common components, which you've seen earlier, modules or parts that form a common structure from which a stream of derivative products can be efficiently developed and produced. So it's the same components which are manufactured, but it ends up as different. And the best part is multiple products can be built from the same framework. If you think of some things, and these are things that you see everywhere, and these are things that we learn together with our kids and everything. So if you think about a simple example of Lego blocks, you could see a standardized set of components here. And the standard there is like, even though there is variety, it has a particular ideas of thickness. It has an idea about the spacing between two protruding spots, kind of like protruding elements in the Lego block. And that is a standard. So whenever that spacing is exactly the same, you can connect two pieces together. And there would be like variety of pieces. Still, you can make something like this, which is as unique as a project. You can bring all those together to make a unique project. There might be some specific things that might be unique for that particular project alone, but if you look at it, 98% of the things would be common. And the good idea about it, if you're making things common, then it can be manufactured in scale. When you're manufactured in scale, better quality, better time performance. But the only problem is like, how do we bring all this together? So that's what we might be thinking about. And it's not just there in the Lego blocks. If you look at manufacturing, there are platforms too. So this is called a Volkswagen MQB platform. So the only thing that is common in this platform is the idea of where to place the engine, what is the distance about all those chassis parts in that particular idea, starting from the center of the gravity of the center of line of the tire, all the way to center of line of the starting of the A pillar. So that particular part is standardized, and they put billions into perfecting that, because those are the things that helps manufacturing and also the ride and handling. Then everything else could be variable. And the result, you could have a Seat Leon, Skoda Octavia, Volkswagen Golf, or an Audi A4, all based on the same platform. So can we do something like that? Can we create platforms in construction? And it's not just the car manufacturing. So you look at engine blocks. So the whole thing idea about that came in as a platform. The shipping container, one of the earliest examples. So the idea about shipping container was like you are going from port to port, and they should have the cranes and the ship. There are like multiple varieties of containers and ships. So it was not efficient. So what they did, they standardized certain things of a container, which is the rectangular cuboid dimensions of the thing, where the anchoring points for the cranes were, how it's stacked up in a ship or in a port. And because of that particular standardization, rest of the things, like whatever is inside, could be the same. They could create that platform, enabled faster shipping, faster unloading, efficient storage, etc. If you come to software systems, Apple in 2007 came up with this idea about App Store, in which there are like certain things all the software developers has to follow as interfaces with an iPhone, and they can create any application. So if you look at the previous phones, you don't have like the plethora of apps that we have right now. You have like 10 or 15 apps that came with the phone. From there, they took it and created like how many apps you want, you can create, developers can create. It's just like an operating system, but it has a lot of integration, like it has a camera integration, it has a network integration, all those things. And it was built progressively over that App Store platform. So I just took the idea about iPhone. It's the same with Android or Windows, or even all the software ecosystem. So what we have is customizability. So do you think two apps in App Store are the same? No, but you can have like a standardization. It works on your phone. Similarly, we can create unique stuff if you have a platform. In construction, it's just like this diagram. You have components, interfaces, manufacturing process assembly, and it can come together in different ways to create unique buildings. So if you look at the kind of processes out there, so there is traditional process, which is a traditional construction. It's a big scope, like unique solution, unique process. Then there is volumetric construction. Standard solution, standard process, volumetric, but there's no variety or customizability. It's similar to the apartment buildings that we can get. So we can get an apartment only in like one or two variants if you are buying it from a big contractor. Then there are like standard solution and bespoke process. So it's like it's the worst. You have a standard solution, but it comes about like any process. Like then there is like manufactured platform, just like unique solution, but using a standard process. That's what we are looking at. And the idea is to combine maximum efficiency and effectiveness. And this travel in the diagonal is limited for traditional construction because of this idea about bespoke processes. So that is why we need platform. And for that, what we need is a technical subsystem and a process. So technical subsystem is, we need to have like a library of things that could work together. So we have talked about all these components, interfaces, standardized manufacturing process. So you need to have a library of these components and products which could actually work together. So they should have standards and design rules, proper interfaces, and a modular architecture. Modular architecture as in it should be built together and it can fit together, etc. And we need to have like a process platform where all this could come together. Start from the design all the way to the demolition of the building and reuse of it. So in simple word, you have a lot of components, and in a project, we will bring about a certain number of components like this page of Lego assembly, in which they clearly say which components in what number we need. And so that will be the product platform and component. This is manufactured. This is project specific, and finally result in a project. In construction, we have a lot of components. They fit together to sub-assemblies or something like this. Finally, it comes all the way to a kind of like a unique solution. It could be residential building, it could be industrial building, it could be infrastructure, it could be mass-produced buildings, anything. And what happens here? So usually our design is like this. We design something that's carried over to construction, and then the information is only transferred downstream. Even here, the information is transferred downstream in terms of the design and customer requirements. Then based on that, configuration is done. So configuration is like the customer needs a whole wall like this, but it is difficult to manufacture. It is difficult to transport because you can only transport something in a lorry. So it should be between the library, this thing of it. So we discrete, it comes what we call as configuration. So we can bring together multiple elements to make that each of it is a component, just like here. Then we think about the production system and we come to the assembly logistics for this customer. But even here, there is a rules and restraint which is going upside. So as I said, like only certain things can be lifted. So there are like a lifting requirement. So a component when assembled as a module should not be greater than a certain weight or something. Then manufacturing a machine can only manufacture in certain ways. So those kind of rules and restraint will be transferred upside. Again, as I said, like the configuration, so you cannot manufacture something in a straight line. So we might need to discretize this. So it's a process of like information transfer downstream and rules and restraints. So here, the idea is we are not starting with a blank sheet. We're starting with a set of standard components and rules and restraint, and we have the customer requirements, etc. And we manufacture the building according to it. Good thing about that, there is a lot of learning. So if you look at that learning cycle in the area, the thing that we mentioned earlier. So if we start with a version 1 of a platform, we start that project and we are learning a lot of things through that project. And we start another project 2 with the same version 1 platform and we are learning through it. But when we, and another project, but we are projecting another project Y1, which is after the start of the first project. We learned a lot of things, we made improvements, and we start with a version 2 of the platform. That means it's already within 3 projects, it's improved a lot. And the people in these 3 projects might be different. All 4 projects might be different, might be different companies also, but still we can bring that improvement. Again, because we started with version 1 of the platform, we can't do any engineering year or year. But when another project comes over here, we can embed the learning from project 3 also. So that's the version 3 of the platform. Similarly, over the years, we would improve just like manufacturing. So this is not the improvement in the product alone. We're also thinking about the process. How fast can we assemble stuff? How fast can we reduce errors in the project? So in this kind of like construction method, we're continuously improving, and it results in better productivity because we are using better tools and better robots, etc. And every project we are improving it. So we know like a configuration of a robot people combination is not correct. We change it. So by the time the next one comes, we have a better thing. The anchor point is not correct. So once we go through certain iteration, we would come about with a standardized approach. And from there, it would be faster than the construction, traditional construction that we see here. So today we talked about why should we industrialize construction. We talked about manufacturing, how it is similar. We talked about industrialized construction, what it is, what is not, why we should think of platforms, and how it would help a project come about with a project and process combination, create a unique project with standard processes. Now, in the last part of the presentation, I would talk a little about how digital methods could help it. And whenever I started, I talked many times that we should not start with a blank page or etc. So starting again with other sectors, you might have seen customization. So one of the easiest things that you could think about is a computer. So if you're ordering a computer, you can order it in different, a same series of computer. Let's say if it is a Dell Inspiron or Dell Latitude, or HP Omni or HP Envy or something like that. You can order it, the same laptop with different processors, a different graphics card, different RAM or different storage, yet it all come together because they only listed in their website only things that could work together. Similarly, for a car, you can have different colors or different engine trims, etc. For shoes, different color combination, or even closer to construction. If you look at the IKEA website or something, you can create a wardrobe from a set of components directly all by yourself, and it will fit together because it only shows things that can fit together, but you have the creativity to make it unique. So that's what a digital configurator is about. It gives you the unique product from a set of manufacturers, and all the rules and restraint things that we have talked about, it's all embedded into that intelligent configuration system. So as a customer, you have a choice and a navigation tool. So we take a base configuration, then we choose a customization, another customization, another customization, another customization, and we get the final product. But in between, with for this to happen, there is a manufacturing portfolio that goes into the system. And so you have like the first option, you have like 1, 2, 3, 4. But if you're choosing a particular thing, only 1 on 2, you can select, you select from that. Then you have something like this, you select from the next thing, and it goes on and it creates a production process. It creates a bill of materials. It creates everything that we need for manufacturing and delivery within the system itself. And that comes to the delivery process. And that can be done in the same with buildings too. So for that, we will have user inputs. There is a bit of a configuration rule. There is a manufacturing process or a product structure and kit of parts, so which we saw earlier, the components, etc. And this configuration rules is the platform, and we get into a customized product. In construction sector, there are different types of configurators that are currently available. So just because we are spearheading towards this thing, we talked about industrialized construction, why we need platforms, etc. So what are the steps towards achieving it? So the first is the planning platform. So if you have like a random site that you have, from there, can you come about with kind of like a thing that can be manufactured? So first type of thing is called a planning configurator. So an example is prismapp.io. So if you go to Prism, just Google Prism app, Bridenwood, you would see this. So Bridenwood is one of the organizations I acknowledged earlier. So I'll just go through this really fast. So you start with a blank place. So this was manufactured for London. So they already have like integration with London information system. So they put the postcode in here. And the moment they put postcode, the map loaded up, the buildings around it loaded up, etc. Then they demolished an area where they were supposed to do the construction. They marked the boundaries, and they were thinking about the floor and the other combination, how many, what type of apartments should come up, and what are the percentage of apartments, etc. And because there's a lot of like previous knowledge around, we did not start with a blank sheet, but with a lot of previous apartment configuration, which we could actually customize. And we could bring it up multiple floors. There can be discussion with designers, architects, etc. while doing it. And it's not a long process. So Bridenwood actually demonstrated building a whole bit of assembly, a design process, all the way up till the bill of materials for manufacturing in less than a day. So they were looking at regulations, whether that can be done. They were looking at configurations, all within this platform. And you can do it just after this session. Just go to this website, prismapp.io, and you can come about with this website, and there are like tutorials for doing it. And they can look at different things like sustainability. They can look lighting simulations. They can do acoustic simulation all the way. Then they were looking at how much can be modularized or not. The whole thing, like system could be traditional construction, manufactured, or a lot of things. So traditional are better customization. All of this can be done within a tool, and it will come about with a bill of materials, which comes as which we could do like manufacturing, which could be manufacturing. And you have like project in the same platform, you created it, then particularly some of these things came as like alerts, wherein some rules were not satisfied, some regulations were not satisfied, all of this within a day for a very large apartment. And once you do that, you can export the whole thing as an Excel or whatever is required by your system. You can export drawings for regulation requirements. You can have BIM models for assembling it. So it comes out as a report. So it's the whole design process, everything together. And the most important part is creating that process platform and technical subsystem and this knowledge about what has to be done. So all the codes are embedded, IS codes or something like that are embedded in here. The regulation requirements, the building codes are embedded in here. So you are reducing a lot of process. So this is what is called a planning configurator. The second one is called design configurator, which is looking at that specific elements of what design itself. So they're like company called Project Frog, which has like a parts library, and then it's an automation engine. So once you get this bill of materials or something, you can use such things to actually configure the project exactly like you want. So this is done at a architect or like concept planning stage. This would be done at the construction just before the design construction stage, and you actually manufacture and construct it. And there is production configurator, which looks at how do you produce these things. So from the same thing, it can be taken up all the way to a system, and you could, like if there are customer components, you could 3D print it exactly like from that base design that we have. And it can be put in, for example, this is a foundation that's being 3D printed and placed in the particular position. Now there are cross-phase configurators, which does all together, starting with the area, all the way to apartment layout, production, and finally ordering. And you get like the final building out there. You also have things like once you manufacture it, you are thinking about installation and the site. So you are thinking about what things would come, and you could do the planning phase a little more faster, and it can also be automated. So in today's lecture, we looked at why we should industrialize construction, manufacturing paradigms, and how traditional construction and manufacturing evaluate together. We looked at what industrialized construction is, what project and process platforms, project process and platforms are, and how they should work together, and how can digital configurators help. So from the digital configurator, you can see that you don't need to start with a plain drawing sheet every time. You have a lot of embedded information that could be like proprietary information of the company or open source information. So it gets transferred from one team to another. In Realis, all you need to know is how to use this information. A lot of repetitive tasks like regulation checking or code checking, etc., are embedded. So those repetitive tasks need not be done again and again for each process. So it actually makes us more efficient, because we are not doing the same task and then again and again. We are leaving the repetitive task to the computer. What we are doing is essentially what we need to do, that is a cognitive ability, bringing all this together, bringing out our creative side, etc. So as conclusion, industrialized housing, it can deliver increased efficiency, better quality, faster delivery. It is better sustainable, because there's a record of everything that is coming together, so we don't have much waste. And these components can be reused in the future, because it's the same components that's there in the database with the same interfaces. So they can be disassembled and used again. So that's contributing a lot to what we call a circular economy, where something that is manufactured is going on for a longer life cycle than just use and throw. We are looking at continuous improvement. We are looking at how things gets changed every time a cycle is going on, and finally coming out with a better version of buildings or whatever infrastructure we are constructing. And the experience is transferred not just from people who have experience, but through firms, but through these knowledge bases as platforms, and it comes about in a really good platform. But what we need standardization. Things should be interoperable. We need to have long-time supply chain relations so that we don't have any reliability issues. And finally, the most important, as engineers, we need to create a change in mindset. So we've been looking at how we construct building almost the same way, all the way from master builders, era of master builders till now. Need to change that mindset. Need to educate the next generation of engineers to think about in a broader scale, adopt principles, adopt robotics, and think about how to best use computers in parallel with our skills, and finally coming about with a change. So that's what we need for this to come together. So with that, I come to the end of the presentation. I'm now open for question. Thank you.
Thank you. Thank you, sir.
Yep. If there are any questions, floor is now open. Either you can put it out in the chat. I haven't seen the chat till now, so I don't know if there are any questions, or you could raise your hand and unmute your mic or something. Organizers can handle that. I would leave the organizers to moderate the questions if there are any.
Participants, it's a time for discussion. If you have any doubts, but if you want any clarification, you can ask either in the chat box or you can ask directly.
Good afternoon, sir. Hello.
Yes. I'm not sure who is talking. So could you please introduce yourself and just start with the question? Okay, I
Sir,
see. Yeah. Yes. Go ahead. Go ahead.
Sir, during this period or during the lots of invention in the construction period, you haven't discussed about what's the problem regarding the labor work if you move toward the industrialization. Most of the work are going through the machinery. So what's the second option regarding the to our labor?
Yeah. So we've studied the idea about the labor in detail, and with respect to Indian construction, NIT Madras, there's a big work by a researcher led by Santosh Loganathan. So they were looking at the labor profile of India. And if you look at any major construction, the labor are migrant labors, which constitute 90% of Indian labor, and the rest then is the skilled labor. So 90% of the labor, they're done by, provided by labor contractors. And if you look at any of the major construction in India, around the harvest time, it gets delayed. That means they go back to agriculture and comes back after that particular idea. So the idea about labor in industrial construction is such 90% of the labor could easily be transferred to industrialized factory or something with lesser labor on the construction. And it's beneficial for the labor because they're getting paid the same. there is enough amount of work, because even with robotics and stuff, we are being efficient, but still there would be kind of people required for handling. Even in manufacturing, it's not all robots, it's people, but we are using them efficiently. Secondly, they have better working conditions. So there are no working from heights and stuff like that in manufacturing. Everything is at a floor level, so lesser risk of falls, injury, etc. So it's better working condition for them. And even in site, there are like things about exoskeleton, etc., that might come into the picture. So there's lesser injury research. So that's the first aspect of it. So we are having a reliable workforce with traditional construction. It can go throughout the year, not stopped when there are like harvest in the plains of India or something like that. And the labor also has better working conditions. So it's a win-win. And like any technologies, there would be some labor loss. With respect to with respect to skill labor, even skill labor has opportunities in manufacturing, not just doing it, but also in the terms of design and thinking about how the process would be, etc. And with respect to loss of labor, there would definitely be something, but that's part of like the evolution. So if you look at artists per se, there would be what do you say? If you think about the computing coming into the artistry industry, so all this flex printing, etc., it came about with a loss of jobs for a lot of people. Then what happened is they did that, and they adapted to that and worked towards the better kind of like picture in which there's more efficient kind of production. Still, you are getting things out. They got jobs, and the same with manufacturing. There are like a lot of labor loss when robotics came in, but it became better and better in a way. So that's what I would like to say, because it gives us a reliable workforce. Some job loss will be there, but it would be in the long term adaptable. And with Indian construction, they're like for the migrant labor or the non-skilled labor, they can always go within industrialized construction or the other one together.
Thank you, sir.
Did that answer your question?
Sir, I have a question.
Okay.
Sir, is it possible a sustainable development by industrial manufacturing?
Yes.
Industrial
Actually,
construction?
Yes. So there's a detailed study about that in a journal called Journal of Cleaner Production. So what happened was like they were looking at the sustainability element alone, and they were looking at resource efficiency and a lot of other factors. And what is reported in that is industrialized construction helps in a lot of ways. One is reduction of rework, obviously. Second, it uses lesser materials than the traditional construction always, because we have efficient construction, efficient design, and it's manufactured. So you look at loss very specifically. So embodied carbon gets all those things is less. The emissions, that is the construction emissions or something, is reduced drastically. I can, if you give me like a few seconds, I will just tell the numbers on that if it is helpful. The next thing is like reusability of components. So we're thinking about sustainability as in something is coming up, then again going back and using the same components coming up. So there's a reusability of components. So that again constitute to sustainability. And the materials, you can choose the materials according to the best way it is assembled, which is nearby, etc. So that again gives better efficiency. So there's a lot of things coming one after the other, but in the end, what happens is like it becomes better and better sustainable. So just give me 1 second. I will tell you the numbers on it if it is helpful. I should have prepared it early, but yeah. Yes, so as I said, like construction sector accounts for 39% of carbon dioxide emissions. The prior research has identified 82.87 are from building material, 6 to 8% from transportation, 6 to 9% from equipments. And industrialized construction has been studied to reduce it by around 30 to 40% emissions alone. It has reduced construction waste, so by 60 to 70%. Then the emissions is around 54.6 tons per 100 meters square on site, whereas industrialized construction, it is just 1.5 tons. So we're looking at like 54.6 tons of emission using traditional construction versus 1.5 tons per 100 meters square. And like looking at equipment usage, the diesel usage was reduced by 51.4% per unit area than construction. And reusability potential. So how much of the buildings can be parts can be reused? So in the studies that have stated, like prefabricated steel, 81.3% reusability, timber buildings, 69.1% reusability, concrete structures, 32.3% reusability. So in terms of sustainability, what we are seeing is like these methods can reduce the emissions, reduce waste, reduce construction equipment usage, and improve reusability of components, if that answers your question.
Thank you, sir.
I think there is another question in the chat about what are the cost aspects in industrialized construction. So just to touch on that, the setup cost of industrialized construction is huge, and it will take some years, a lot of change in mindset, a lot of collaboration between stakeholders to bring about it. So initially it's high, but once it is set up, it can run through really fast and the cost will bring down. And some of those things of pre-manufactured, for instance, without industrialized construction itself, in prefabrication, the GFRG housing in India, the glass fiber reinforced housing, that one reduced the cost by 30% per apartment, reduce the time. That is just prefabrication alone, without the industrialized housing. So the thing is, how do we reuse things together? So there are a lot of startups and big companies coming into the picture. So there is Blocklock in Sweden. Then I think Project for Blocklock. Then a lot of Silicon Valley startups are there. Then the major contractors like Langerock, Maze. In India, like we've been in conversation with Larsen and Toubro on how to think about industrialized housing and digital construction together. So there are a lot of things coming together. So it's like the starting part, it might be a costly, but per apartment in the end, it is going to be cheaper. The initial development, as I stated, like the platform development for MQB, it was billions of dollars, but they made a lot of money afterwards with a lot of cars manufactured using the same kind of like techniques across different companies. So as per cost aspect, for the user or customer, it is going to be cheaper. And it's not going to be cheaper with the idea about like losing quality. You're not getting a substandard product at a lower price. You're getting what we call premium quality at the cost of traditionally housed or even cheaper construction and the latest aspects for the user perspective. For the manufacturer and the constructor, it's going to be a higher initial investment, a change in mindset of the company, a lot of training. So there would be cost aspects. So that's kind of the investment that they have to do to bring about this change.
Any other question?
Participants, any doubts?
Hello.
Yes.
Am I audible?
Yes.
Yes.
Thank you so much, sir, for the answer about cost aspects. So can you please, what do you think, at what time, in which year, by which year India will be focusing on industrialized construction? Like right now, we don't have industrialized construction, right, sir? So what do you think, according to you, like how much years it will take in India to like popular this particular thing?
I think yesterday, because India is already there. So it's kind of like a perception that India has not reached that place. So from around 2015, India has been working on this. There was a major company in India. Unfortunately, they failed. They did not fail because it was India. It failed worldwide, called Kitera. That was just because of their business model. So this prefabrication was the industrialized housing principle is already there in different small companies in India. It's only like the code. Future is already here. It's not evenly distributed yet. So it in the next few years, let's say next 10 years, you would see a higher uptake, it becoming a norm. But if you are asking about whether it has already reached India, it's already has like 5 years ago. I think even more than that, but I've been recording the observation from around 5 years ago. And companies like Larsen and Toubro has been thinking about like factories around different parts of India, and also with logistics and other constraints. So it's in a way, it's already there. It's not evenly distributed yet.
Thank you, sir.
Participants, any other doubts? I think there is no doubt. Once again, any doubt, participants, or you can please type in the chat box. I think it's over. So we can conclude this session. Once a great man whispered, feeling thankfulness and not expressing it is like wrapping a gift and not giving it. So I am very much delighted to have give a vote of thanks for this wonderful session. And I am on behalf of Civil Engineering Department. On behalf of Civil Engineering Department, I thank oh, sorry, actually I have muted my mic. So on behalf of Civil Engineering, knowledge and share your findings, the topics. Why should we industrialize the construction, manufacturing paradigms, industrial construction, etc. As in the conclusion statements are said, by industrialized construction, we can increase the efficiency, better quality, sustainability, and continuous improvement. With all, I am thanking you, sir, for delivering such a very interesting and inspiring topic. Thank you all.
And thank you very much for the organization for inviting me. And thank you all for listening.
Thank you, sir. With all that, we are concluding the first day of 5-day FDP on modern trends in civil engineering construction. And the next session will start tomorrow at 9 a.m. So thanks for all participants. Thank you all.